Okay, so today we are starting with the section of pyramids problem. So see the question: a triangular pyramid of base edge 40 mm, axis length 60, resting on one of its base on HP, with one of its base edges parallel to VP. So that means we understood the first position here. So it should be parallel to the VP. Now you see this, they have given information about the section plane. Section plane passing through one of the base corners of the pyramid, and the two slant edges at a height of 20 mm and 30 mm above the HP cuts the pyramid. Draw the front weave, sectional top weave and true shape of the section. Determine the inclination of the section plane with HP. So first we are going to construct a triangular pyramid of base edge 40, axis length 60. Okay, so first I'm going to draw one line here. So we're going to construct VP HP on the HP plane. So there is a triangular pyramid of base edge 40. You can see here base edge, it is parallel to VP. So parallel to VP means, so we have to consider, okay, so this is what the position which is parallel to VP 40 mm. Okay, now take the compass. Since it is a triangular pyramid, so you measure 40 mm in compass and cut the arc. Can I join it? Okay, since it is a pyramid, okay, since it is a pyramid, so we have to construct the slant edges here. So take the exact middle points and draw. So draw the slant edges. So here we have to draw the slant edges. Okay, so you can give the namings A, B and C, and this is O1. So we just retain only the slant edges here. The remaining part we are going to erase. Okay, okay, now we construct the front weave. So front weave, they have given an axis length of 60. Okay, so axis length of 60, you have to consider, draw an axis here. Okay, since it is a triangle pyramid, so the front weave, what we get, that is a triangular face. Okay, it is 60. We'll show one dimension here. So it is 40. Okay, now we have done with the uh, first position, top and front view. Now we can see section plane passing through one of the base corners of the pyramid and two slant edges at a height of 20 and 30. Okay, here I'll be mentioning A dash, B dash, C dash, O dash and O1 dash. Say the height we should consider. Okay, so this is what the 30 mm height, you can see 30 and one will be 20. So we have to draw one line here. Okay, So this is what the 30 mm height I consider with the question, and 20 mm height is this. Okay, for the two slant edges. So I'm going to mention this. This is 30 and this is 20. Okay, now we have to draw from this corner point to this line, line 2 dash, line 2 dash, line 2 dash, line 2 dash. Okay, so like this we should draw the section plane or the cut plane. Okay, yes, yes. Okay, this is how we should mention the section plane. Okay, just I will extend a little bit this one. Okay, so it is done. Now we can mention the cut points. Okay, so this is your cut point 1 and this is your cut point 2, this is your cut point 3. Okay, so we can project it downward. You can see on the slant edge of A dash and O. So if we just project a straight line, so we're getting a point number 1. Okay, similarly say for the point number 2. Okay, for the point number 2 it's not there, so we are going to consider this point number 2 here on the slant edge. All the things we are going to consider on the slant edge. Okay, now I am going to project it downward. Okay, project it downward. Since we don't have the exact point here, so we should have this point on this vertical edge OB, because you can see B dash O dash, this is what the slant edge, so we have to get it on the slant edge of this. So for this what I'll do, I will take compass and I will measure this length. Okay, measure this length from here to here, and I'll go to cut the arc, draw an arc. Okay, so this is your point number 2. Okay, in the same way point number 3 we're getting here, exactly here. Okay, so no need to worry, we're getting on it. Okay, now we can join to get the sectional top view. So join it. Okay, now we are going to mention with the dashed lines here. We're going to hatch it. Okay, so this is the sectional top view. In the same way we can do the sectional front view. So you can see we have done with the sectional top view. This is done. Okay, so sectional top view in the true shape we should do it. So for that so what we do, so we have to mark it perpendicular points here. You can see for this 1, 2 and 3 I'm going to mark the perpendicular points here at 90°. Here, exactly here, and exactly here. So there are 3 lines I should draw here. Okay, I'm going to extend it a little further. I think okay, after this I'm going to draw one parallel line here. parallel line. Okay, in order to draw the true sectional shape, so we should consider this distance. Okay, and this distance also we have to consider. So where the in order to cut the arcs here, we should measure the distance from this here. Okay, what is this distance, and what is this distance, and what is this distance? So I'm going to mention this distance. Okay, this is q1, this is q2, this is q3. Okay, so measuring this distance, so what we do, so we are going to cut the arcs. You can see from here to here, measure it, and cut the arc. This is your q1 length. Second length what we have from here to here, so this is your q2. Finally, this is q3. So now we have to join all these points. Okay, okay, so this is what we have done with the problem. Okay, this is your front view. Okay, sectional top view, so we're going to mention it. Okay, this is true shape. Okay, then finally we have to find out the inclinations here. Okay, we are going to find out that. So angle of inclination here, I think it is 45 degree. So this is what we have done with the problem.